Hello everyone. Let us now discuss how can we solve this problem. Power of 3. So we are given with an integer n. Return true if it is a power of 3. Otherwise return false. An integer n is a power of 3 if there exists an integer x such that n is equal to 3 power x. So let us take n is equal to 3. Now 3 can be represented as 3 power 1, which is nothing but 3 power x. Now let us take n is equal to 5. Can we represent it as 3 power something? No. So we'll return false here. Now if we can represent it in power of 3, then we will return true. If not, we'll return false. So we have 27. Now 27 can be represented as 3 power 3. So we will return true here. Now n is equal to 0. We can't represent 0 in 3 power something. So we'll return false here. Now n is equal to minus 1. All those negative integers we can't represent in 3 power something, including 0. So 0 and all the negative numbers can't be represented in 3 power something. So we'll return false. Now, if you see, the constants are minus 2 power 31 less than or equal to n less than or equal to 2 power 31 minus 1. So, how can we solve this? But before going to the optimal solution, could you solve it without loops or recursion? Let us go with recursion first. What I'll do is, let us take n is equal to 5. Now 5 by 3, what it will be? 5 by 3 will be 3 ones are 3 and the remainder is 2. So it will be 1. And 5 mod 3, the remainder will be 2. But I should not get this remainder. Only when n is equal to 1, I'll return false. Now let us take something like n is equal to 27. N is equal to 27 and let us take 27 by 3. 3 nines are 27 and 27 mod 3 is 0. Now let us take this as n. N is equal to 9. 9 by 3. 3 threes are 9. Now 9 mod 3. The remainder is 0. Now let us take this as n. N is equal to 3. 3 by 3 is 1 and 3 mod 3 is 0. Now I have 1. Now if I got n is equal to 1, I'll return false there itself. So first thing, if n is equal to 1, I'll return false. And the second thing, if n is less than 0, sorry for the mistakes. So here, if n is equal to 1, I'll return true, right? If n is equal to 1, I'll return true, as 1 is something like 3 power 0 is 1, so that I'll return true. Now after that, what I'll do is n is less than 1. That means it is either 0 or negative values. Then what I'll do is return false. Now, at the case of 5, I can't represent it in 3 power something. So, if n mod 3 is not equal to 0, then return false, right? So from this I'll take a recursive code from this so that you can understand. So if n is equal to 1, return true. If n is equal to 1, return true. If n is less than 1, return false. If n mod 3 is not equal to 0, return false. Else return, I'll write this as bool recur int n, return recursion of n by 3. That's what I did here. So first I started with 27 and n by 3, 9 is made as n, and for this 3 and 3 is made as n, and 1 is made as n, and if n is equal to 1, I'll return true there itself. Now at the main function, in the main function, right, in the main function bool power of 3, if I'm not wrong, int n. So I'll just return recursion of n. So we'll be having this code as a recursion code, right? But how can we solve this without recursion? That's what we are asked with. So if you see, let us take about 2 power something. 2 power 0 is 1, 2 power 1 is 2, 2 square is 4, 2 cube is 8. All these are bit representations: 1, 2, 4, 8, 16, and so on. If in the bit representation of and I have only one set bit wherever it might be. But if I got only one set bit, I'll return true. But in the case of 3 power something, it's not like that. Now let us solve this by using 2 power this, right? So 2 power 3 is 8. Now let us take n is equal to 1. Now 8 mod 1, 8 mod 1, is it 0? Yes. Now 8 mod 2, is it 0? Yes. 8 mod 4, is it 0? Yes. Now let us take 2 power 5, 32. Now 32 by 8, sorry, 32 mod 8, is it 0? Yes. Now let us take 64, 64 mod 8, 64 mod 8 is 0, right? 64 mod 4, 64 mod 4 is also equal to 0. But what I want to say is, let us take the largest number in power of 2 and divide it by n and get the modulus by n. If it is 0, then we'll return true. If not, we'll return false. This is how we solve for power of 2. But what about power of 3? The same thing. Same thing, right? So, what is the largest power of 3 in the range of let us take what is the range. So the range is 2 power 31 minus 1. So let us calculate this range of 2 power 31 minus 1. So let us calculate what is 3 power 18. So 3 power 18 is 387420489. Now what will be 2 power 31? Now 2 power 10 will be 1000 approximately. Why? Because 2 power 10 is equal to 1024. So let us take something like 1024 into 1024 into 1024 into 2, sorry, into 2 minus 1. Let us calculate this. 1024 into 1024 into 1024 into 2. So let us just copy this. So the value is 214,748, 83648, but minus 1, right? So 68, instead of 8 I am taking 7. Now let us take 3 power 19. So let us take this value 3 power 19. Now let us take 3 power 20, what it will be. So 3 power 20 will be 3, 4, something like this. If you see, 3 power 20 is exceeding our range of 2147843647. If you see, they are in the same digits place, they all have same number of digits. Now only 3 power 19 is lesser than the range, right? So what I'll do is 3 power 19. What is this value? 116 So if n is greater than 0 and also 3 power 19 is 116 mod n is equal to 0, then I'll return true there itself. So this is how we solve this problem, and I have given the code link in the description. Go and check it, and thanks for watching this video. Do share, like and subscribe to my channel.